All right, so I hope to be fastish so we can go to lunch. So yeah, already it's like Multiplanes. This is a collaboration between Simon Fraser University and Adobe Research. And yeah, we're presenting our system, and I'm Mayra. And okay, so what is Multiplanes? Multiplanes is a system for 3D immersive sketching. So opposite to the previous project, this is completely virtual reality. And 3D immersive sketching is drawing in virtual reality. It usually uses a 6 degree of freedom input to control the stroke. Most of these systems use what's called a freehand drawing, which is you grab the controller and you move it and then you draw. And yeah, another feature is that users can walk around the drawing and see it from different perspectives, which different to like 3D AA design and other 3D projects, they can actually be inside, like move around the drawings. And yeah, what are the advantages of these systems is that precisely users are inside the drawing, they can go inside and back and around their drawings, and they also can like draw directly in 3D. So instead of having to use any of the methods of 2D drawing into 3D, if you want to draw in depth, you just push your hand and move it. And what this makes is that the drawings and the users, especially the users, can see the spatial relationships of their strokes better. And this is like an open area of research, and there are a lot of other projects, and some of the earlier ones are, for example, 3DM from Butterworth and HoloSketch from Deering. And right now, the commercial systems are, for example, Tightbrush and Quill. So yeah, there's a big problem with 3D immersive sketching, which the talk like before mentioned, and it's like it's less accurate than 2D drawing and 3D drawing in real life. And this means that the degree of details and of accuracy that someone can do with a pen and paper is not yet achieved in virtual reality. Okay, so why is that happening? And there are a couple of challenges. And the first one is, okay, and yeah, the video, is the depth perception. Most of the current virtual reality headsets use stereo displays to display the 3D objects. And stereo displays have been shown to be like, have problems with the depth perception of users. And what this makes is that users try to position their strokes in a specific way, but they're actually not positioning there. And it has a lot of problems with snapping and like finishing the stroke where they want. Another problem is that users are controlling a 6 degree of freedom, and in the drawing, this translates that they actually have to consider the depth of their stroke, not only their position in a plane. And what this makes like everything harder is to make it harder for the user to see like their visual motor and cognition challenges are more challenging, because their eye-hand coordination is more affected by the depth perception and the 6 degree of freedom control. And to make everything worse, there's a lack of physical surface. So users get tired and they need to like consider that. So the thing we would think is like not everything is bad. There's actually are ways to improve the user accuracy, and I'm going to talk about those. So the first one is to use novel metaphors, which means like yes, you have a 6 degree of freedom control, but you don't need to follow the hand to make the strokes. And there's a big range of different metaphors, from simple ones from just like drag and dropping the strokes directly into the virtual environment. And the example that I'm showing is to using 2 hands to control the stroke creation. Another way is to use beautification, which is to transform informal inputs into formal and structured ones. Most of these methods are automatic and use some kind of algorithm to detect what's happening. And again, there's like a big range of different beautification methods. Some that is not properly considered beautification could be like smoothing the curve to use to remove the abrupt change in position from the stroke. But more like formal beautification methods actually detect what type of stroke, the shape the user is doing, and beautify based on that. Another one is to use drawing surfaces. And yeah, those can be like real drawing surfaces or virtual drawing surfaces, and there's also a huge way to create those drawing surfaces. And the example I'm doing, which is from Aurora at CHI this year, they create a surface and users can draw on top of that surface. And finally, yeah, give users a physical surface where they can draw on. So we saw those methods and we saw the challenges of 3D drawing, and we propose another, which is Multiplanes. This is an assisted freehand virtual reality sketching. Our system is thought as an intermediate state between completely pure sketching and completely pure computer-aided design. So what this means for like drawing is like, okay, I know like I want to draw a table and the general shape of the table, but I want to be a bit more specific, like how are going to be the legs of the table? Are they going to be a little bit to the side, or are they going straight? And is it going to be a rectangle or is it going to be a square? So we wanted to allow users to draw that in virtual reality. And yeah, so thinking about that, we have this high-level design goals. And the first one is we want users to be more accurate when they're doing spatial relationship between their strokes. And the second one is we want them to reduce the user effort to draw accurate shapes. So what this means is that we want users to have the flexibility of freehand drawing, where they control the stroke and don't have to use other or learn other user interface methods, but at the same time they can do perfect shapes. Okay, so how did we implement those high-level design? So we create some user interface design goals. We base this on previous guidelines, for example, for 3D drawings by Aurora et al. That guide last year, and for another for 3D user interfaces from Stuerzlinger and Byungmoon. And the guides are there, but in summary, what we want to do is we want to diminish the depth perception issues of 3D drawing by providing users with drawing surfaces. We want to remove the difficulty of creating perfect strokes in virtual reality by providing beautification and other visual features to allow users to see what they're drawing. And yeah. So how did we implement that? So we, the prototype is implemented in Unity, and we basically created 4 different models that are interconnected between each other. And I'm going to explain those models. Okay, so the backbone of our project is a 3D snapping model. The goal of this model is to automatically detect how far the user is from their feature, or the closest feature. And this feature is the stroke, and inside the stroke, the closest vertex. And this is important because, as I said before, users have problems with depth perceptions. So we are wanted to avoid relying on the user depth perception and actually having the system tell the user, you are close enough to actually be closer, or you are not so close. Okay, so how do we choose the distances? And if we use an empirical choosing distances, we just ask people to draw, and we base the beginning of the distances on the depth perception of the user, on the depth perception theory. And we have 3 categories. The first categories is the vertex, and this category is more related to snapping. So the controller needs to be closer than 5 centimeters in depth from the stroke, and it's for the snapping behaviors and snapping user interfaces. The second category is stroke, and the controller needs to be between closer than 5 centimeters in visual depth from the stroke, and inside a 50 centimeters radius around the stroke. And basically the behaviors of these user interfaces is to draw in a plane, so to show guides inside a plane. And the final one is the plane, which is the controller needs to be farther away than 5 centimeters in visual depth, but closer than 50. And this one is to show behaviors related to the spatial relationship of the stroke. So it's not only you are drawing in that plane, but you are how the other planes relate to the plane that your previous stroke is. And how to change between these different guides is just to move your controller closer or farther away from the feature you want to draw. So this is more the algorithm that works, but this algorithm doesn't provide any user interface. The user interface are the other 3 models. And the first of that model is the automatic snapping plane, which you will see in the video working. And the goal of this model is to remove the perception issues of the stroke creation process, and also to allow users to see relationship between strokes. So I'm going, my new stroke, how is going to relate to the strokes I drew before. And to achieve that, we have 4 different planes. And to identify between the planes, we just change the colors. So the green plane is for a parallel relationship and a snapping relationship. So this is my controller is parallel. The blue plane is a completely new relationship, so it's a completely new plane not related to anything else. The yellow plane is for perpendicular relationships, so the new stroke is going to be, and that's it, perpendicular to the other ones. And the orange one is for acute 45 degrees, so it's in between the completely orthogonal planes. And how users can control the planes? So basically the planes are on the user controller, and when they rotate their controller, the planes change. And yes, when the user is not drawing is when the plane changes, but when the user is drawing, the plane stays static, so as not to confuse users. The next point is there it goes. Okay, the beautification trigger points. So this one is, I need to turn this on. to show users, they are like cubes or spheres inside the virtual environment that, again, show users help with the depth perception, and also they work, because they work as snapping guidance, but they also show users like future relationships. So if you're drawing a stroke and want to be completely like the same size as the other strokes, it will show you where to end your stroke to have that size. And the goal, as I say, it's like also not only like related to depth perception, but also spatial relationship, spatial perception of the user. And how we create that? Okay, so we create them. We use from the beautification model that I'm going to explain next. We detect which type of stroke is, and based on the type, we show specific beautification trigger points. And each, like, there are beautification trigger points for only a specific type of strokes. And then we use the guide and the snapping 3D model category to like know what to show. And these guides, how they work, and you can see them, is like when the user is not drawing, they work as like endpoints and starting points of the stroke. And when the user is drawing and they get crossed by the controller, they start an automatic beautification. And yeah, so what is this automatic beautification that I've been talking about? So this is our final model, which is a real-time beautification. So based on the intended shape of the stroke, what we do is we detect it, and we automatically and in real-time beautify based on that. Currently, our system works with lines and curves and circles. And yeah, what the goal with this is we want to avoid like handshakiness and to remove the difficulty to create perfect shapes. And how the system works is that we take the current controller position of the stroke, and then we calculate the curvature of the shape of the stroke. And if it's based after a threshold, we calculate it as a line or as a circle. And what is like important of this real time is that user can accept or like modify the beautification while they're drawing. So for example, if they want to draw an ellipsis, so the system will first start like detecting a circle, but if the user continue doing an ellipsis shape, it will like stop the circle beautification and do the ellipsis. So yeah, once we like design our system, we decided to evaluate it. We did two different user studies with novice users. One was a qualitative user study and one was a quantitative. So the first user study was the qualitative one, which is a usability study. So this one, our main questions was, does our system work, like our design work all together? And it actually helped user improve. But the more important question was, is it easy to use, or is it like because it's like a lot of correlated models that are working, like, or is the user just getting lost? Because we were afraid that user would just see like points showing up and like colors changing and would not understand what was happening. So we ran the user study to like see if that happened or they actually understand what was happening. And yeah, we had 8 participants, 5 women and 3 men. And we asked participants to draw the shirt that you are seeing on the study. And all participants did 5 different drawings. So the first 3 were only using one specific part of the system. So for example, in the first drawing was only drawing surfaces. So we removed the beautification and the beautification trigger points, and they only do the surfaces, and so on with the other 2. And once they finished that, we did the full system evaluation, and then we asked participants to draw with the freehand, with no guides at all. Because not all our participants had done virtual reality drawing before. And the data we collected was, while they were drawing, we asked them to follow the think aloud method. And after they were drawing, we asked a questionnaire. And between each drawing, we did an interview with them, basically asking, like, did you like the system? Did you find it useful? What did you not like? And we also record the participant screens to see what was happening. So yeah, here are the outcomes, some of the outcomes of participants did. So the top row was with multiplanes and completely freehand, and the bottom one is without like each different part of the system. And so yeah, in general, we find that the drawings look better, but we were not so much interested in like how much better, but what our participants said. So we analyzed the questionnaire. This was a 7-point Likert scale questionnaire where we found, like, for each specific model, how they like, how easy they found, how the speed of the users they found, how accurate they feel when they were doing this model, and their overall preference. And we actually found that it was quite average. which was disappointing. But yeah, but we asked, like, why did participants find it average? So we went to the interviews to see, like, what was happening. And we found that actually the participants liked the system and liked what was happening. But they had problems with their prototype. So for example, like some 2 or 3 participants had problems with the beautification. And it was, I'm trying to beautify, create circles, and the system is not doing circles. So we like went back to the prototype and say, okay, so we need to tune our beautification parameters more. Other problem was like, oh, I'm trying to find a specific plane, but it keeps jumping between planes. So we also like tune our jumping, like our threshold to when is a parallel and when is a free plane. And once we like fix our prototype, we did the next study, which is a more formal quantitative study, where we compare the multiplanes with freehand. And we had 2 different hypotheses, and the first one is multiplanes is better than freehand, and the other one is 2D is better than 3D drawing. In this specific context of our study, 2D drawing is drawing in virtual reality, but shapes with no depth, so drawing squares and lines and circles. And 3D drawing is drawing shapes with depth, which is cubes and pyramids and rectangles. Because this was a 2x2 user study, each participant drew 4 times, and we have 6 participants, 3 men and 3 women. And you can see the examples of what we show our participants before they start drawing, like the example of what they're supposed to draw. And here are some results of the user study. So in general, we found that just multiplanes visually was better than freehand. And also we found that 2D drawings are better than 3D. But we wanted to do an analysis of like qualitative analysis of how our strokes were better, how much our drawings were better. So what we do is we use a coding method that Viz et al. Proposed that see how much the stroke is. So it has like 4 different categories, and it uses a specific, it gives for each of those 4 categories a score of the lines of each drawing, and then you add like all the scores and get a final score of the drawing. And the categories are, for example, like deviation from the starting plane. So if you start in this plane and should finish here, if it finish here or finish here. It also, if when you finish your stroke, it finish touching other stroke, or you actually not finish that stroke. If when you are drawing, how much your lines move or like shake. And the other one is, I don't remember the other one, but it's something similar, sorry. So yeah, what are our results? Like the results of our analysis. So yeah, we found that multiplanes drawings got better stroke quality than freehand drawings. And we also found that 2D drawings are better than 3D, like drawings are stroke quality, it's better than 3D drawing stroke quality. We did not find an interaction between interaction and drawing type. And yeah, how we did analyze this, we used a repeated measure ANOVA with an alpha of 0.05. And yeah, here is like important to mention that one limitation of our user study is that we only have 6 participants. So to verify our like results, we calculate the effect size of our study, and we also like consider that the difference between the means on each of the groups, which you can see there, is larger than 1 standard deviation. So in conclusion, we present Multiplanes, which is a virtual reality freehand drawing assistant. Multiplanes consists of 3 different modules that help users draw more accurate and see better and remove some of the depth perception issues of virtual reality drawing. Our work is aimed to help non-artists and like non-designers to like draw better and draw perfect shapes. We also did 2 user studies that evaluate our system, and we found that in a usability study that participants were able to understand what was happening, also find our system useful, and also in a qualitative study that the stroke quality of the multiplanes drawing is better than freehand. So yeah, that's all. Thank you. Do you have any questions?
Okay, are there any questions? In this nice hot room, there's one.
Yes, thank you. Very interesting work. I was wondering whether you consider any behavioral data about your users, like the velocity of movements, for example, like saying if you move fast, you want more guidance from the system, perhaps, whereas if you move slowly, you can work more accurately. And whether, I mean, at some point you could even consider learning about different user types, how accurate they move, how much data they have, and so on, and whether how you would use such information in your system maybe to improve it.
Okay, so what we consider about like the guides was to have a maximum limit of guides, especially the sphere, because there was like after a threshold. Right now you can only see a maximum of 10 points each time, because after 10 points it was just like points. So we limit that, and that's why we consider like if we have too much guides, it will confuse the user. So more like we want more guides when the user is being slower. We want like less guides because it's confusing.
What about user behavior, like moving faster, moving more slowly, remaining at the point, things like that?
Well, what we like, not precisely how you like are like saying, but we consider speed when the user hits it, because like if you have a guide and you hit it and you were actually going to this place, like you will just like see guides. So what we have is like user needs to like decelerate towards the guide, and then it's activated. If not, it's like not considered, like it's going towards somewhere else.
Thank you for the very interesting talk. I'd like to know your opinion about what happens when users use your system compared to freehand conditions with respect to the way they sketch and the way they think, because sketching is described as a very fluid ideation process, and when I look at the videos you are showing, I think there are so many widgets, and users have to consider how to control the system. I could think of that it somehow interrupts the ideation process or the creative process. I'd just like to know your opinion about this.
Okay, so what we found, like, and especially like in both of user studies, was that users started thinking more spatially. So like what we found is even in the think aloud, when like we hear the recordings, they start saying like, oh, I want the green plane, I want the yellow plane. So they will like start thinking of like parallel or perpendicular. So we did find that, and in the freehand we did not find that. So I did not calculate that and like not see like specific like result, but I feel that users start thinking more spatially.
Okay, are there any further questions? Otherwise, I would have one probably last question. So it's really closely related to the previous one. So if you look into assisting systems, because it's somehow an assisting system, it's also very fast perceived as very restricting and a burden at certain points, because it tend to be that you cannot leave this assistance and say, okay, now I want to have freehand sketching. I don't care about precision and these things. So my question is just, did you have any kind of comments got in this direction that the system is too restrictive, or it's not changeable enough in a sense?
Well, I think it has like maybe the shapes we asked, which was like a house, which is a cube. So they were like shapes thought for the system. So yeah, but maybe is this constraint, but because the user can select to follow the guides or not follow the guides just by moving the controller away or getting closer. I don't remember any like user complaining about that.
Okay, good. So if there are no further questions, so thank you very much again.